So today we're also going to be talking about what a median is. We talked about the maximum, the minimum, the mean, mode, and range before. Now we're going to add one more term to those organization of data terms that we talked about. So we're talking about today median, which is simply put just the middle number in our data set. So let's look at an example of how we can find a median. So if we have this set of information here, which tells us a list of students and their test scores. Now, I've organized their test scores from the maximum down to the minimum. They've been organized that way. And when I do that, I can quickly glance at this and see that the middle number, that's my median, is 85. So it's pretty easy to find when I have my information organized from greatest to smallest or maximum to minimum. However, what if I had a set of information that was even? On the last one I had 5 students, so I'm going to have one student that's in the middle. But if I have 4 students, I don't have a student in the middle. I have these 2 student scores that are in the middle together. Well, I can't just say they're both the median. I have to have one median answer. But I am going to take both of these scores and I'm going to add them together to get 173 and then divide by 2 because I have 2 scores that I'm adding together. So I take 173, the sum of the scores, and divide that by 2, and there is my median, 86.5. So that's my median when I have an even number of data. Now, what about if both sets of data in the middle are the same? So again, I have 4 sets of data and now they're both the same. Do I have to go ahead and add them and then divide by 2 again? Well, no, I don't, because if I did that, I'd end up getting just one of these 2 numbers. So if you have the same number, then your median is just that number. So why would we want to use the median instead of maybe like the mean or the average? Well, let's look at an example. So here's another set of information. This time it's students and their ages. So we did a survey of a class and we found out that the age of the students, and I listed them by least to greatest this time. So once again, I have 5 pieces of information, which means I'm going to have one in the middle, and so that means right here 13 is my median. So that's my median. Now to find the mean, I'm going to add all of the ages or all of the sets of information, come up with a sum, and then divide it by the number, divide that sum by the number of data points that I have. In this case, I have 5 students, so I'm dividing it by 5. So in this case, the mean, after I divide that out, is 13. So my median and my mean are the same thing. They're 13. I could really say either one, and that would give a good representation of what a typical student in this class, how old they are. But let's change it up just a little bit. So we got the same group of students, only now the last student is 54. And I know that sounds kind of crazy, but let's just say for argument's sake that they're 54 in a class of a 12-year-old and 3 13-year-olds. Well, we still have 5 bits of information, so I'm still going to have one that's exactly in the middle. Now remember, the median is the middle number, so my median is still going to be 13. So let's try and find the mean. Well, again, the mean, I'm going to add up all of the bits of information, and that gets me 105. And then I divide by the amount of information that I have, which is 5 students. And now my mean is 21. So now if we look at the median age of a student in the class and the mean age of a student in the class, which one is more representative of the actual populace of students? Well, the median is, because we see that we have 4 out of 5 students that are 12 or 13 years old, only one of them is older than 13. Our mean, or the average, would tell us that the typical student in this class is around 21 years old. But that's not really true. It's just one student who's above that age. The median tells us that the typical student is going to be around 13 years old, which that is more accurate.